Reading week 6 was primarily about magnetic dipoles and electric potential energy. Some topics that were previously introduced to us but were also discussed in Reading week 6 include magnetic dipoles, Coulomb's law, which explains the reciprocity between forces and how the force on 1 by 2 would be equal in magnitude to the force on 2 by 1. Reading week 6 also discussed how the magnitude of mu is the magnetic dipole moment and how we demonstrate the right-hand rule to determine the direction of a magnetic loop. Also, something that we had previously learned is potential energy and work, and that work equals force times distance, and the change in energy is equal to work. So if potential energy equals 0, then the work is equal to the change in kinetic energy. Some topics that were not previously introduced to us include talking about the current loop B, field on axis, and perpendicular axis. Additionally, we talked further about Newton's third law and reciprocity. A new topic also included the magnetic dipole and the magnetic north pole and geographic north pole. This is significant because of navigation. Magnetic dipoles on the perpendicular were also discussed with the formula mu initial over pi times 4 times mu over r cubed. Other new information learned from reading week 6 included electric potential energy and electric potential. It also discussed the change in electric potential energy equaled negative the work done by the electric interactions. Another thing that we learned was that the change in electric potential is written as delta V equals delta UE over Q. After discussing electric potential further, the lecture videos put UE on an energy graph and worked us through multiple more examples. The part of the lecture that interested me the most in reading week 6 was when they discussed how delta V and delta UE differed. Even though they are related, delta V equals negative E times delta R, and dUE equals Q times delta V. This is related to my area of study because I would like to become involved in research dealing with these topics, despite not being a physics major. Although there were multiple challenging topics in reading week 6 that were discussed, the most difficult concept for me to understand was when we were discussing magnetic dipole moments. Although the lecture described that mu equals I times pi times r squared, I was still a bit confused. So, although the lecture gave information about magnetic dipole moments that described it as the vector that points in the direction of the magnetic field at the center of the loop, it also described the direction can be found using the right-hand rule, but I still did further research. My source was off of Britannica, and that source described magnetic dipoles further and defined the magnetic dipole as a measure of the dipole's ability to turn itself into alignment with a given external magnetic field. It also states that the magnetic dipole moments have dimensions of current times area, or energy divided by magnetic density.